Hello. All right, this is the fourth video in our series on Introduction to Java. This video will primarily focus on executing, compiling, and debugging a program. And so we'll focus a little bit on the different types of errors you're going to encounter, and then some strategies in terms of how you can actually debug your program. But first, let's do a quick review over some of the things that we covered in the previous video. We primarily focused on discussing what the primitive data types are in Java, and then also talking about how to declare and initialize variables. So let's skip forward here. All right, so here's the program that we left off on last time, where we declared variables, and then we also initialized variables. So on line 5 here, we said int a number. That's declaring, that's reserving some space and memory. And then we set a value on line 7. So we assign the value 23 to a number. And then number 9, this is a different data type, different primitive data type, double, and that has a decimal. And we assign 2300 to the variable salary. Now, we could also do something called variable reassignment. So for instance, if we say, we can use the salary variable again and say salary equals salary times 12. And that's permissible, right? So salary is going to hold a different value from what it originally held when we declared it. And so that's permissible, and that's called variable reassignment. All right, we're going to continue to explore more about variables and initializing variables, but there's one thing that I didn't mention in the previous video, and that's this reserved keyword called var. So if we go back here, and I believe this came out with version 11, my memory serves correct, Java version 11, where instead of actually declaring a variable such as int or double, you could just go ahead and use this reserved keyword called var, and then what happens is that at runtime it'll imply which data type it should receive based on what is being assigned to the variable. So based on what's on the right hand side of this sign here, it'll imply if it should be a double, it should be an integer, and so forth. So it's a really helpful tool in terms of just declaring something and initializing right off the bat, and then letting the compiler determine which data type should be assigned. All right, so let's keep moving forward here. So compiling, debugging, and executing programs. We already talked about how to compile a program. We showed you 2 different ways of doing that. One, just kind of bare minimum with just your source code file, and then you can just run the commands Java C for Java compiler, and then the name of the file. That's going to create this, what they call a bytecode file or a class file that contains the bytecode. And that's what the JVM is going to use to basically communicate to your machine and interpret it into machine code. And then you can also just use the regular setup that we went through with Visual Studio Code that has the various extensions that you can use. But when you're building a program, you're going to run into different types of errors. The 3 errors that you'll primarily see when you're building a program are these 3 here: syntax errors, logical errors, and runtime errors. Let's take a look at all 3, and then I'm just going to talk about some different methods in which we can use to help debug our program. Syntax errors. So a syntax error is when you have something, let's say, misspelled, or a reserved keyword that's misspelled. You're missing a semicolon, the incorrect casing, whether, let's say, for instance, string, in this case here, is incorrect. Right, so here you'll see the incorrect version, you have the correct version, and these are just common errors. But what happens is that when you go to compile your program, it'll compile, but then it'll throw some errors. It won't fully compile, and it'll give you a list of errors that what they would call syntax errors that you would need to fix or need to handle before your program is ready to execute. And so things such as like misspelled words, so S here for string, we need to uppercase that. And at the end of each statement, there should always be a semicolon. And then here we have a misspelled method, right? It shouldn't be print line, it should be print ln. So within these two statements here, right, we had three different errors, syntax errors. And syntax errors are easy to be notified of, because the compiler, when you're going to run your program, is going to notify you that you have an error. And it won't let you execute your program until all the syntax errors are fixed. Now, it's a little harder to actually identify logical errors. And logical errors are such as incorrect calculations, using the wrong variable for output. So you may, for instance, use price here instead of using discount or whatever it may be. And those are hard to detect. There are different methods that we can use to actually help us understand or find a logical error, and there's something called unit testing. And unit testing helps us to kind of put in some information to see if it returns the right information that we're looking for. And we'll talk more about that when we get to modularization. But I would say out of all the errors, logical errors are the ones that are hardest to detect. So let's look at this incorrect version and then look at this correct version here. So the incorrect version, everything will compile and run at this point. If I take this program here that I have highlighted and I would run it inside of my, I would run this program, it'll run, right? But it would not give me the correct answer that I'm looking for. And so the issue with this particular one here is this statement here that I have highlighted. What it's doing here is just making a calculation of price minus 1. So it's saying 23 minus 1, that'll give us 22. And then it's going to take the discount 0.10 times 22. And that's not what we're looking for in terms of the price. What we're looking for is what is the final price once the discount is applied. And so here you'll see that the calculation is now rectified. And so we'll say 1 minus the discount. So 1 minus 0.10, which will give us 0.90 times the price, 23. Then that'll give us our correct price. And so, again, this here is just a minor error in calculation, but that's an example of a logical error. So this next error is called a runtime error. And with a runtime error, the error occurs during the running of the program. And so when your program executes, it'll get to a particular calculation, or it'll try to assign a variable to another variable that has a different data type, and your program will error out and it will stop running. And that's a runtime error. So one example here is what we're seeing in the incorrect example, is that we're trying to divide by 0. That's not permissible, and so your program will just error out and just shut down. To fix that, you would do something called a try-catch block. And this here just basically notifies us of the error that happened, right? The catch block. And we'll talk a little bit more about try-catch exception handling a little bit later. But there are certain things that your computer it can't do, right? Or you're asking the computer to do something that it's unable to do. And that would be considered a runtime error. Best way to rectify a runtime error is to use the try-catch block to figure out if that error occurs during the runtime of your program. A practical example of this would be, like, let's say, for instance, you have a program that's reading from a spreadsheet. It's reading a bunch of different records from a spreadsheet, and it comes across a particular record that has a mismatched data type. Your program should be able to correctly handle that, and this would be the way that you would want to correctly handle it, by using a try-catch block. So if the error does happen, it'll just be notified that, hey, this is the error that happened. Notify us of it. And then there's another one where you can say finally, and you can move on with the rest of your program. So runtime errors they happen, and sometimes they happen by accident. But there are different ways that we can be notified of that error by using a try-catch block. Before we go in and talk about debugging strategies, there was one thing that I want to go back and that just came into my mind, that there was three errors that we identified. It was the uppercase string, we needed a semicolon, and then the print line the method was spelled wrong. The other error here is that it's missing a closing bracket, and this is a very common error. syntax error that folks tend to run into. To fix this here is that you have two opening, one bracket for the class and then one bracket for the main method. And then we need one closing bracket for the main method. So something that looks like that. That ends the main method, and then we have a closing bracket for the class. So that's the other error. So there's 4 errors in this example. All right, so let's talk about some debugging strategies. So the whole point of debugging is to really identify what is being assigned to your variables, what is happening during the runtime of your program. And so with debugging, we can actually see the variables being assigned at a slower pace. And so we can step through the program and to see what is happening. And so if you look at this image here, let me just zoom in here, you'll see that here's the program that we've been using for our example when we declared initialized variables. I put some numbers here, 1, 2, and 3. It's kind of giving the steps in terms of how you would go about debugging. But the first step in debugging is that you want to set a breakpoint. In Visual Studio Code, you will set the breakpoint in this little gray bar area here right before the numbers. And so you can click and a red circle will pop up. And basically what you're doing is you're clicking in a particular area in your program to say, hey, this is where I want my program to stop. I want to monitor everything up until this point. I want to see how the variables are being assigned up until this point. And you can step back and you can step forward, but it's really just to see what is happening. Is a number being assigned the correct variable? Is salary being assigned the correct variable? And you can use these controls here in number 3 to step through your program. So let's do a quick example of this. Debugging really helps out with logical errors. For instance, you may be building a program and you're doing some type of calculation in that program, but you're not getting the correct output or you're not getting the correct answer. That's where you will want to go ahead and debug your program. So let's do a quick example of this here. What I'm going to do is jump back to the issue that we had previously in the logical error slide. I'm just going to take this code and I'm going to bring up my editor. Okay, I just pasted that code in here. There was an error that I had to fix on the print line. I think it was from the syntax error I had to fix. But I'm going to save this here, and what we're going to do is we're going to debug this program. Now, this is the code that's not correct. It has an error in it, right? A logical error. And that error is through the calculation. But if we want to debug and to see what price is being assigned, we can go ahead and set a breakpoint. And so in this case here, I'm going to set a breakpoint at line 9. And then here, because I set a breakpoint, when I press this play button, it's going to automatically put me into the debug interface. So right now I'm in the Explorer interface, and it's showing me all the code, the file structure. But when I press this play button, you'll see that the debug interface is going to show up to the left here. So if I press play, it gives me my controls. But then here, you'll see that it has the local variables, and that's just my variables that are my main method. And that's what's being caught onto the stack right now, which is my main method. We'll talk about the stack and the heap a little bit later. But right now, within my main method, these are the variables that have been allocated or been assigned a value up until this breakpoint on line 9. Now I can step through and see what price is going to be reassigned to. So right now, price is assigned to 23, and it's showing me that here in the debug screen. And then here, if I scroll down one more, right, price now changes to 2.2. And what I did was I stepped down past the breakpoint, and then you'll see that price is now reassigned a value. And so I know that that's the incorrect value, and that's where debugging comes in, really becomes helpful and help you understand like what is happening and say, oh wow, okay, that's where my error is at. It's in the calculation. That is not the price that I'm looking for, right? And so that's a quick example of how to debug. And so we can do that, especially with some of your shorter programs. Now, some of your longer programs, we have multiple methods. That's where unit testing would be more of a benefit. Another way to help debug your program or to minimize, to try to figure out where the error is coming from, is to comment out your code. And so you could do like a single line comment and comment out an entire block. And so run your program until run your program to make sure that everything is running correctly. And you can continue to add more statements in to try to identify where the error is coming from. So you can add this back in, run it, and say, hey, oh, that's where the error is coming from because the calculation is wrong. But especially with some of your longer programs, that may be helpful. You can do a block comment / and then comment out several lines of your code to minimize to minimize where the error may be coming from. So just a few strategies that would help with troubleshooting and debugging your code. All right, before we end this video, I'm going to talk about two more things here. And that's I want to talk about the scanner class to add some interactivity into our program. And so everything that we've been doing thus far has really just been outputting information to the console. But what if you want to accept user input? You want the user to input a number into your program. You can use something called the scanner class. And what that's going to do is it's going to read in, it's going to accept the input from the console. And you can use that user input to do calculations, to assign variables, or do whatever you want with it. So here's some methods from the scanner class. So next line, next byte, next short. And so these methods align with the various primitive data types. So you want to choose the correct method in terms of what data will be assigned to the variable that you're reading in. So for instance, here's an example program. To use the scanner class, we have to create a scanner object instance. And so you have to say scanner, there's the data type, the object data type, and then this is the variable name. It's SCN. You can name that anything you want. We're going to create a new instance of it. And this has to do a little bit with object-oriented, create a new object instance. And we'll talk more about that a little bit later in class. But just know that for now, just follow this syntax, and this is what you just have to use at this juncture to read in data from the console. So for instance, if we're reading a name, we want to use the next line. So you can use the next method, or you can use the next line. The next line is basically puts the cursor one level down within your terminal or your console. And what this is going to do is accept string input, and it'll assign it to a string data type. Here you have next int. So if you want to read in a numeric value, you can use the next int, and it's going to assign the numeric value to an integer data type, or a variable that's declared as an integer. And so there's, like I said, there's a scanner method for each of the primitive data types. So next int, there's next double, and then for string, there's next line, and there's next to read in string data. Last but not least, we're going to talk about the system class, and this is where you want to begin to learn how to use the library that Java offers. We talked about the Java API, and system is one of those packages that is automatically imported for us by default. And we need that to even use the system.out.println line, right? So if you look back at this program here, we have system, right? That import statement is automatically that package is already imported for us on our behalf. And here's some of the methods that we can use. So here's just a sample program that shows you some of the power of the system class. It's able to get into our actual machine, our computer, and to do some input and output, but also read some of the data that's from our at the system level. And so this program here makes use of this method called nanotime. And what we can do with this is pretty cool, is that we can actually time anything that's in between this statement here that I'm highlighting. We can time how fast this code executes in nanotime. And we can translate that to seconds as well. And so there's an activity that we'll walk through that makes use of this, where we'll time the typing of you typing out these team names. And so feel free to study this, play around with this. You can take this code, run it in the editor, see what it outputs, and I would encourage you to kind of play around with it and even explore some of the other methods within a system class. All right, this video is at 20 minutes. I'm trying to keep the videos a little shorter, but the introduction, the videos are going to always be a little bit more longer because there's so much stuff just to cover and to talk about and to get people familiar with some of the fundamental concepts of Java. All right, until next time, see you later.